Welcome to this TBC APM video. We want to cover in this video series the adjustment report, and we want to take a deep look into the different sections of the adjustment report. Today we will start with the first part, and in this case here we want to give an overview about connectivity and also camera calibration, standard deviations and accuracy. The training material will be cut into these different sections. So this video here will first cover just the overview and the connectivity. About the adjustment itself. So of course the adjustment itself is not the only thing. So we start already by preparing the project correctly. So being very clear about the correct settings that we define for the camera, but also the strip definitions, then the rotations of the camera, also the flying height, terrain height. There are many things that can go wrong in the project setup, and typically over 80% of the errors happen in the project setup. Therefore, initialization would be a very important topic, which is not covered here in the adjustment report, but is very important that we get good results in the adjustment report. But with this side note, let's go into our adjustment report itself. And there are different approaches how to do a correct reporting and report reviewing. And I will here use as my guideline the reference manual from the Info Match AT software. And here there's a chapter called Check Triangulation and Adjustment. And here we really want to make specific main topics, which is the block stability. And in the block stability, we are taking a look at the connectivity and the geometry and the accuracy itself. So typically the standard deviations of our orientations, of our control points, of our checkpoints. So these and also the residuals of them in our measurement. In Match AT, because why do I mention Match AT? Because in our info software, the engine behind Trimble Business Center APM is also partly coming from the info development team, and therefore here also in the background there are a lot of functionalities running and also reports running. And there were, in this case, three major parts from this engine, which is the multi-photo measurement tool in Match AT, the analyzer, and the AAT log file. And these three tools, let's call it this way, they have been combined to create our TBC APM report file. And we tried really to pick from these different tools the tools that make for us the most sense to represent the final adjustment result. And therefore we want to go through this adjustment report and explain what is behind it and also what we need to take care when we are running these reviews. So in this case, let's start with the connectivity. And the connectivity is really more based on the images itself. So the image, in this case here, we will take two important things. One is the connectivity of each single photo itself, so the distribution of the type points in itself. And in this graphic here that we can see, there's on the left side an equal distribution of the type points over the whole sensor of the single image. In the middle one, it's not perfectly distributed everywhere. And in the last one, only sections of the photos are covered with type points. And coming from a photogrammetric background, we're always talking about Gruber positions. So we would cut this photo into 9 areas, and then we would take a look through these 9 areas And at least in each of these 9 group positions, we would like to get tie points in it. This was the classic old way. And this changed, of course, with the digital sensors also coming into the game, and also with the flight patterns that were used to fly. So therefore, when you not fly anymore 60-30 like in the old days, but afterwards there was a lot of 80-40 flown in photogrammetry, and now with drones you fly 80% overlap. This group positions is not so more important, but the idea behind it is the important thing. We want to have everywhere over the whole sensor distributed tie points, and we want to have them as good as equally spread. I mean, it doesn't help me to have hundreds of tie points just in the lower left corner. So we want to have everywhere over the whole sensor tie points. Important is this for 2 things. First of all, if I have everywhere tie points, then my capability to calibrate the camera for the sensor is ideal. So that means I have then everywhere a measurement on this sensor existing, hopefully multi-matched, so more than 2, 3, 4 times connected each one. And therefore, this already is a very good indication that I was able to use the whole sensor and also to keep these measurements through my whole adjustment without losing them. Yeah, so that means after the adjustment, if I have everywhere still my tie points and they were in a good way adjusted, so I have a good interior accuracy, then this would be, of course, something that we are looking for. A second thing is that, of course, I want to have tie points that are connecting between the strips. So that means in the points that are here in the upper, higher part of this sensor, they have a much higher probability that they can also be measured in the second or third strip above. And the same thing, of course, with the tie points on the lower part. Or also tie points completely on the left side of my sensor, they are probably also with the second and third image inside the strip able to connect. And of course, this is something that we want. We want to have multiple connected points, because every tie point that is more times connected than 2 has some redundancy, and therefore we have a better probability how this point is defined and measured. Our enemies for this part is the texture. So if you have a lot of forest area, water areas, or low textured areas like snow or desert where you don't have many differences in the image, this will make in general this tie point definition and measurement difficult, and therefore it can be that these areas of a photo will not be able to generate tie points for itself, and of course even more difficult to transfer these points between the photos to generate the tie point matching. And therefore this is something where we are related or dependent from texture. And as I mentioned already, the overlap, so I need to have, of course, images to match each other. In our protocol, we will find this, for this task, a statistic, and it's the histogram of distribution of tie points. In our case, because this is more a visual check also very often, so we can do this also visually inside of US Master, for example. We did it now in our protocol in a very simplified statistic, and again, it's now using these group positions. If they are making the most sense for us, this is another question, but at least this gives us an indication if in these 9 sectors, at least all my photos have tie points, or if there are some images that are missing 2 or 3 or 4 group positions in itself, which would mean I have a larger part of my image not covered with tie points. A second statistic, or second connectivity, what we are checking is the connectivity between the photos, which is, I would say, the most common part. And therefore, here we want to take a look how many measurements each type point has. So is it a 2 times connected type point? Is it a 3 times, 4 times? So one, let's call it one object in my image. Let's say I take a road section, a crossing, and this crossing in my image number 1 can be seen in multiple other images identically, so the same pixels representing the same crossroad section. Then this type point will be transferred and matched into the other photos. And our main interest is to have these matches between the strips. And the reason is the complexity. So it's more difficult when a drone or a plane flies along a strip. It's easier because typically it's always pointing in the same direction. If there's some side wind, then it flies always with the same kappa value or the same off angle. But then when it comes back, in this case, then it has a different rotation. It's perhaps not perfectly flown with a parallel strip. It's perhaps the strip is a little bit undulating to the first one, and therefore getting points between the strips is the more challenging part. Also the viewing aspect. Yeah, if I take my first image, looking here down, and then the second one, then still my building is leaning similar from the first to the second image. My trees are covering the same amount of street that I cannot see. But if I come from the other strip, then the trees are leaning perhaps in the opposite way, and then seeing a street from the other strip is more difficult or not possible, and therefore type points typically tend to approach more inside a strip than between the strips. And because we want to do a block adjustment afterwards, connecting the strips to each other to make it homogeneous is a very important part. And therefore, this is one thing we are very much looking. We are checking this in our protocol with the type point distribution part. And also, a second protocol entry is the statistics of these type points, which is the second slide here after the type point distribution. In general, we also want to see that the type points are equally distributed over the complete block, so that that when we adjust the block, then of course we don't have weaker and stronger sides, and to achieve here a nice block adjustment. So let's take a look at one of these protocols. I will open here Trimble Business Center, and I'm using here the demo data from the DJI that you can download from the TBC site. And to review the protocol, you can go after you have successfully run it. In case you want to see how to process here, I'm adding here some videos where you can take a look how to adjust data. And then you go to the Adjust Photos in the Photogrammetry tab, and then there's a pane opening up, the Adjust Photo Stations, and here you can see in the header Flight Mission Adjustment Report. Let's click this one here, and then we can take a look at this report. And here I want to now focus on these things that we have seen in the slides. So I will scroll here up and down all the time. So first, let's start with the first one, and this is what I want to show is the type point distribution. So the type point distribution has a legend, and we can see it here. The red dots mean that this point has something between 1 to 8 measurements for each type point. If we want to look more closer, we can go to the next slide, and here we now see statistically how many 2 times connected, how many 2 to 4 times connected, and so on. And this is depending from each protocol. So if I take a different other protocol, then I can see here for this project that we have here a different distribution. Let me go here to the next one. Here another distribution. Here we have another distribution. And here we have another distribution. And Of course, again, depending on the overlap, how much my photos are overlapping, I can reach more measurements for one type point. So here in this report, if I go to the statistics, then we can see here up to 24 connections was here available. In this one here, we have up to 28. In this one here, we have up to also 28. And in this one here, we have up to 36. So this can vary between how you fly your project. If you have an 80-80 or 85-85 or 75-75. So this can always vary from project to project. But still we want to see if we have enough points that are at least more than 4 times connected. So I'm in these graphics here, for example, interested in everything that is after the 4 times connection. So is this now here 50% of my type points, or is it less than 50% that are only 2 or 4 times connected? And the reason is very simple. When we take a look here at our flight, then if I fly with 80% overlap, then one type point typically can only exist in 4 photos in one strip. Because then my first photo is not touching anymore the 5th one, so no type point can be more than 5 times connected without existing at least in 2 strips. So this is depending from your overlap. And therefore, everything that is 5 times or more times connected, at least statistically I know this type point exists in 2 strips. Then of course we also have sometimes at the end of these strips some cross strips, or sometimes the drone just flies a curve. And then of course here there will be here more possibilities of connectivity. But still then therefore I also want in a statistical matter to see that I have a large distribution of points. So this is now here just looking on a histogram how many type points, and here in a numerical way I can see how many percent or numbers of type points are 7 or more times connected. Of course, in general, we want to have many multiple connected type points. This is our main goal. What do we learn from it? That means if I have many multiple connected points, then typically I assume I have a good block connectivity or block stability, which is important. I want that my images tie well to each other. At this moment, we don't have any accuracies. It's just about a connectivity, a block stability. But this is one of our major issues in drone flights, because the drone is not like an airplane flying very stable. There's more wind dependencies. So therefore, being able to connect all these photos together and being able then to connect them is a very important part of our adjustment. And this brings us back to our very first slide in this protocol. And when we go up here, then we see here in the flight overview the green dots and the red dots, and hopefully we don't have a single red dot. And the reason is we want that all the photos are able to be measured together in one block. If you would have a single or a few red ones, then hopefully very at the end. Perhaps the drone at the end took off very extreme, changed drastically its movement. It perhaps even tilted in this case, and therefore the photo looks totally somewhere else. But in general, this is really what we want. We want that all my photos that I was collecting during my flight are able to be connected. Then, next thing that we were mentioning is the distribution over the complete block, which is then the next slide here. And I mean, I think statistics always should never surprise you. So I want that my best connectivity is in the center of the block. And therefore I want to have here these blue and green dots, but the color is perhaps not the most important thing. It's more the largest amount of connections of type points should be in the center. And in the outer part, I have here these red dots. So where I don't have so much geometrical potential to connect, but in the center I have a large amount of connectivity available. If you have a lake, then you should normally see it also here in the tie points, because then this area should have less connectivity. It's more difficult to match. If you have forest areas inside your project, again, these areas should then have a lesser connectivity because it's more difficult to measure tie points between trees because they occlude areas, or also sometimes they are moving through wind, and then we have not so good tie point measurements. And therefore, this graphical overview gives us an impression how the tie point distribution went over the whole block. Okay, let's sum it up also with the last parts. Mentioning before at the slides are these group positions, and therefore this is this histogram here, histogram for distribution of tie points. So we really just simplified and cut all the photos into 9 areas, these grouper areas. And then we were looking at, in my project here, 369 photos. And for all these 369 photos, how many of my photos did, in this case here, have in 8 grouper areas tie points existing, or how many did have, in this case, 9 group positions with here some measurements. And therefore we see in our case all our 369 photos have in all 9 group points, they have tie points. So that you see here 8, 7 or 6 group point positions only covered with points are not existing, they are all 0. So we really have in this case here all our 369 photos with points in it. At least it gives us an impression, okay, we were able to measure everywhere on each image in these 9 areas tie points. So we should have an equal distribution of tie points in these photos, which is a good starting point for our adjustment. Okay, so far for this topic connectivity in the whole topic of adjustment report. A few previews, of course, is we didn't talk anything about accuracy, or in this case here, standard deviations. So, of course, looking at this topic in itself, we want to still see how this relates into our accuracy. So one thing would then be, for example, the RMS values of the tie points, which we will take a look in the standard deviation topic part, and also the inner accuracy. So typically this sigma naught value here is an interesting topic with tie points related. So it's very much related with the tie points because it's our main amount of measurements comes from the tie points. So this will also be a topic that we want then to take a look in the standard deviation part. Okay, so let's sum it up also with success and failure. So what can cause us to fail in the connectivity, in the tie point extraction? We call it, well, it's a relative orientation. Some people call it, well, it's not really a relative orientation because it's part of the block adjustment. So it's an integrated process, but still, let's call it relative orientation because most people then have a feeling. Of course, it is the coverage. Yeah? So that means if you fly in 80% overlap, then you have many images looking at the same position, or the chance that many images are looking at the same position is much higher. And therefore, we will not have gaps and we can connect the photos to each other. Of course, it's depending from your wind conditions and also your weather conditions. It's also depending from the radiometry of the photos or the texture also of the photos. The terrain itself can also be a challenging part. So for example, here we have a larger part of our project with trees. Also a height difference. So between here, the upper part of the street and the lower part here on this part can here differ more than 20% of our flying height, which also causes in this case then to make it more difficult to match also part. We see here also in our case, but this is not for the tie point extraction, will later on be then the adjustment. If we don't have control points in all the areas, even more here, not in the lower part of the block, but only in the upper part of the block. But this is another topic here. So therefore, a good thumb rule is to fly with an 80% overlap. 80% in strip, 80% between the strips of overlap, which is a good starting point at the beginning. You will face much less problems in your connectivity, in the type point extraction, and therefore, when you have a good coverage and good type point connectivity in your block, then the further steps of the absolute adjustment will then be much more easier to be handled. Second, weather conditions, mainly also wind conditions. They are really impacting the flight even more, not only that then the images are not looking straight down, but also when a wind hits the UAV in a quick way, then it will try to autocorrect, but it still moves very quickly. It will blur the image, and blurred images will also give you then more trouble into the type point extraction. Third, fixed focal length. So really, I mean, this should be basics, but just to be sure, we will talk this in camera calibration, that really we have here a fixed focal length in your drone implemented. No auto zoom in this case. Changing the focal length is a no-go in photogrammetric approaches. It will really make your results bad. And also, of course, in the type point extraction, this will already start to have an influence. And I want to finish with the side note slide again. And it's really prepare well, because it's a long journey, and therefore there are many things that also can happen in the project setup. Double check everything. I know it's really boring and not nice, but this is really where many errors happen during the processing. So really to take care of all your ingredients that you put into it. So I hope you enjoyed the first part of the adjustment result review, and we will then continue in the next chapter with the camera calibration. Thank you for watching and have a nice day. Goodbye.